Okay, we're going on with the kite, right? So we have a kite here, and we have the first thing, everybody knows the shape of the kite, right? Sorry, I drew a kite there. Right, the kite, everybody knows when the kites that you buy and the ones that you fly in the wind, that's the shape of a kite, okay? So two pairs of adjacent sides are equal. What are the properties of kites? Adjacent sides are equal. What does it mean when we have adjacent sides? This side is equals to that side. Can you see these are next to each other and we're matching the lines, and these sides are next to each other and we're matching the lines, right? The one diagonal bisects the other at 90 degrees. So we're drawing a diagonal from there to there and a diagonal from there to there. They are bisecting at 90 degrees, means they are cutting at 90 degrees. The longer diagonal bisects the opposite angles. So the longer diagonal bisects the opposite angle. So what it means is, you can see this diagonal is longer than that one. It cuts those angles in half. So that's why they've got two dots to show you that this angle is equals to that angle, and this one is cutting that one in half, so this x is equals to that x. So that's another property you need to know, that they are cutting each other. The longer diagonal bisects the opposite angles. One pair of equal opposite angles. So the ones that are equal is these ones here. This angle is equals to this angle. So what you need to know about the kite is that the longer diagonal, you can see it's cutting those angles in half. So if this angle was 100, this would be 50 and 50. If this angle was 60, this would be 30. If this whole angle is 60, this will be 30 and 30. So that's the rule. So if they give you one angle, then you know you can figure out the other one, right? But remember, this whole angle, if this is 50, it does not mean that this is 50, okay? But this angle is equals to that angle. These opposite angles are equal of the kite, right? So you have to remember it from the picture. So that's the properties of a kite, and again you have to know the properties and then answer a question on the kite, right? A parallelogram, and then I want you to remember that we call a parallelogram a palm. Okay, so everywhere where you see a palm, you need to know that they are talking about a parallelogram. Both pairs of opposite sides are parallel. Again, like a square, a rectangle. Can you see this? A rhombus was like turned, a square turned. This is like a rectangle turned. Okay. Both opposite sides are parallel. So that side is parallel to that side, and this side is parallel to that side. See the double arrows? We're matching that, and the single arrows. Both pairs of opposite sides are equal. So opposite sides are equal. Can you see the two lines there? We're matching that to that. So if they tell you this is 5, what does it mean? That that is also 5. The opposite side here is equals to the opposite side there. So if they tell you this is 3, that line is going to be 3. Okay, diagonals bisect each other. So what it means is the diagonals are bisecting each other. Okay, so then if you're measuring the size of the lines, can you see there's a 3 there that's matching to that? So this part is going to be equal to that part. Okay, and then that part will also be equal to that part. So remember, when we're doing questions on the parallelograms, you'll be able to see. Now what's very important to remember is that both pairs of opposite angles are equal. Okay, and this comes up a lot in the questions. This angle is equals to that angle. Can you see there's a double line? And then this angle is equals to that whole angle. Okay, so the opposite angles are equals to each other. This one is equals to that one. This one is equals to that one. Remember, it's not a square. It's not cutting at 90 degrees. Okay, it's not bisecting the angles. Can you see they're unequal? So they didn't tell you that the diagonals are bisecting each other. All you need to know is that the opposite angles of a palm are equal. That's showing you that this angle is 50, that angle will be 50. It does not mean those two angles are 50. If this is 40, that one will be 40, which means both pairs of opposite angles are equal. Okay, so that's a palm. So let's go through one or two examples before you do the exercise, right? So this one is saying, identify the quadrilateral below and then determine the value of A and B. So if you look at the shape now, you must be able to know what shape it is, right? Can you see it's a parallelogram? The quadrilateral is a palm, right? You will note in the reason column we abbreviated parallelogram as palm. So look at how we have to write geometry. Please, I don't want to see anybody's answers where you've just written down A is 35, B is 8. That's 2 marks instead of 4 marks. Remember now, the statement is, they're saying, identify the quadrilateral. So we found what it is. It's a palm. Then determine the values of A and B. Now we need to look at A. Always in a geometry question, you can't just figure something out on your own, in your own brain. There's some answer there that's linking it to the picture, and if you know, now what did we do now? Opposite angles of a palm are what? Are equal. Which one's opposite? This angle is opposite to that angle. So that's why you've been given 135 degrees. So you can say that A is equals to 135 degrees. So you get 1 mark to say A is equals to 135 degrees. But why did you say that? Opposite angles of a palm. So you have to give a reason. We know it's a palm. So when we have a palm, the opposite angles are equal. You don't have to prove that. That's been proven by mathematicians. All you need to know is that they are equal, and I'm saying they are equal. Okay? Now I need to say what is B. You see the small letter B? Now I'm saying B is 8. I'm going to get 1 mark. Why did I say B is 8? Because opposite sides of a palm are equal. Then I get another mark. Can you see how simple it is? The first step is to learn the properties, and then you go to the examples. Right, let's do a rhombus. This one is a rhombus, right? So identify the quad below. How is it? How can I see that it's a rhombus? Easy way. It's like a square that's turned, right? You can see there, okay? The quad is a rhombus. Now they're saying determine the value of P, Q, and R. So you have to find P, Q, and R. And remember I told you there's something there in the picture that's going to tell you that you need to know about a rhombus, okay? And then that's how you're going to find P, Q, and R. So what they're saying is P is 68 divided by 2, okay? 68 divided by 2. So this one here, can you see 68 is this whole angle here? I think there's this one supposed to come here. Diagonals of a rhombus bisect the diagonal bisects the angle here. If you go back to the properties of a rhombus, this diagonal and this diagonal is cutting this angle into 2. So what does it mean when we're bisecting an angle? So then we can take 68 and divide it by 2. So we're getting 34 degrees of each one. What is my statement? P is 34 degrees. Okay, and why did I say P is 34 degrees, right? Diagonals of a rhombus bisect the angle, so this angle is equal to that angle there. So this whole angle here is going to be also 68. And then to calculate P, we're going to divide 68 by 2, and we're going to say that P is 34 degrees. Okay, so if you see here the properties of a rhombus, right? Look at the properties of the rhombus. Both pairs of opposite angles are equal. Okay, so now what mistake they made in that example is they should have first said, right? They should have first said that this angle here, SPQ. So if you're writing, let me see there properly, SPQ is equals to QRS. The angle by R there. So this whole angle is equals to that whole angle. We first had to prove that. And what will our reason be? Our reason will be opposite angles of a rhombus. So that's already 2 marks. Now we're saying that's equal. So what we're saying is, therefore, SPQ is equals to 68 degrees. Then we're going to say that now that the diagonal is cutting that angle into half, and that's why we divided it by 2. So this is a very important step that they should have written there. Okay, so leave this one out because it has this one has theorem of Pythagoras. Wherever you see this theorem of Pythagoras, don't do it, right? Okay, but let's go through this one here. We have to still do Q and R. So what is Q? Okay, we're looking for Q now. So there's Q there. Let's see. They're saying Q is equals to 9 centimeters. Where's Q? 9 centimeters. Remember now, all the sides of a rhombus are equal, just like a square. All the sides are equal, so then you have to say Q is 9 centimeters. Why I'm saying that? Because they're sides of a rhombus. So you see how you have to know the properties of the rhombus first and then answer the question. Then they want to know what's R. R is what? 90 degrees. Why is R 90 degrees? They drew that like round to confuse you, right? Diagonals of a rhombus bisect each other. They bisect at 90 degrees. That is a rule of a rhombus. So that's how you prove R. Okay. So let's just go through this. We won't do the bottom part, right? ABCD is a rhombus. Now they told you it's a rhombus. So in your brain it has to click. What do I know about the rhombus? What is equal? What is parallel? All those kind of things. Diagonals AC and BD intersect at M. So they're telling you this point is M, right? With AM equals to 3 centimeters. AM is 3 centimeters. And MB is 4 centimeters. Can you see here? MB is 4 centimeters. Now you need to remember already, it must click in your mind that these are bisecting here, right? So determine the size of the angle X, that is AMB. AMB. So X is 90 degrees. Diagonals of a rhombus bisect at 90 degrees. So why are you saying that is 90 degrees? Same like there. Diagonals of a rhombus bisect at 90 degrees. Now they want you to find AM. Okay, AM is equal to, they want you to calculate the length of AC. Where's AC? The full diagonal there. Okay, AM is equals to MC. AM is equals to MC. Why? Diagonals of a rhombus bisect each other. What its meaning is that this diagonal is bisecting this line AC in half. It cuts it in half. So this is 3 centimeters, and that is obvious that it's 3 centimeters. So you can see what you need to do. You're just going to add it together, and then you're saying that that is 6 centimeters. But look at the amount of marks you're going to get to say that AM is equals to MC, 1 mark there, and then the reason 1 mark. Then you show this mark here. Okay, so don't just see that now you know a rhombus, that this is equals to that and this half is going to be equals to that half, and you just say 3, then you're losing so much of marks, right? So leave this part out. We'll do it when we do theorem of Pythagoras. So what you need to do today is exercise 12.5. You have to apply yourself. It's not hard, it's very easy. You go through the shape first, identify the quadrilateral, right, and then determine the value of the sides and angles marked by the lowercase letters, which means you must find A here, B here, here you must find P here, Q here, okay, the lowercase letters. So you're going to do this exercise today.